Hello, my name is Kim, professor of Kalasangam University, India. Today's first lecture of the Fourier transform. Let me explain the meaning of a transform. General meaning of transform. Then how to transform a variable u to v like this. Then function of u to v. How to transform u to v. Okay. For example, in case of x over t to x over s, of course s is a complex number. We call this Laplace transform. And x over n, in case of a waveform x over n to x over g, we call this G transform. And also x over t to frequency domain x over f, we call this Discrete-time Fourier transform. And also in case of a discrete x of n to x of f frequency domain, we call this Discrete-time Fourier transform. For transform u to v, okay, then f over u is here. We multiply the g function over g u v, and if we take integral with respect to variable u, then variable u will be removed like this. Then finally we can get the variable function of variable v. We call this general concept of transformation u to v like this. Also discrete time case also. F of n and is multiplied by g function of g mn, and then we summation we carry the summation through the variable n, then n will be removed. Then finally we can get function of m like this. By the way, here GUV and the GMN is there. What kind of these functions can be used? For this, we need to use some kind of orthogonal functions. But there are many kind of orthogonal functions for transform this kind of complex exponential function used very popularly. Also, g power over g mn. uv is continuous case, mn is discrete case. Okay, for my lecture, this kind, let me review notations: continuous time domain, discrete time domain. For the time, lowercase over t and the uppercase, this is period. Discrete case is n, this is m. Also the t lowercase is a variable, and the t is constant, this is a period. Okay. And the unit is second. In case of discrete time, this is a no unit. Also, of course, nm is integer also. And the frequency, uppercase of f, hertz or 1 by second. In case of discrete time, we use lowercase of f, is the normalized frequency by sampling frequency. Also you can see here, no units. Angular frequency, omega equal to pi f and omega equal to pi f. In this case, the unit is radian. In this case, radian per second, because this is radian. This is 1 by second. Okay, waveform x over t, x over n. This is a lowercase. This is lowercase. Therefore, usually we can represent the waveform with a lowercase. And spectrum, we usually represent uppercase like this: x over f omega x over f like this. The Fourier transform, Jean-Baptiste Joseph Fourier, French. He was mathematician, physicist, and also historian as well. Just before I mentioned, for transforming u to v, we multiply by guv and integral with respect to du. And for this, as just before I mentioned, we use this kind of complex exponential function. Then we can rewrite like this. Instead of this, we can use also instead of those waveform. Then now here, function of t, function of the omega and the t, with respect to t, then t removed, then the omega is removed. This is x omega. We call this spectrum. And also, this is a real number. This is a complex number. As you know, this from the complex number, we can take norm over g and angle over g. This here also, from this, we can take norm of x over omega. We call this amplitude spectrum. And angle over x over omega, we call this phase spectrum. We call this Fourier transform. Especially, there is continuous time. Therefore, we call this continuous time Fourier transform. Sometimes you can rewrite continuous time Fourier transform also. In case of a discrete signal, here, now you can say instead of integral, you can use the summation x of n multiplied by exponential to the power of minus j omega n. Then here the n removed, then the x omega. Also like this, you can use amplitude spectrum, phase spectrum like this. We call this also spectrum. Especially x of n is discrete time signal, that we call this discrete time Fourier transform. Thank you so much for your watching. Today I explained the basic concepts of a variable transform and how to extend the transform from general expression to Fourier transform. Next topic is the formulas of Fourier transform in detail and conditions for x over t to have a Fourier transform. Sometimes we call this Dirichlet conditions. Please look forward to next lecture. Thank you very much.